The next theorem that we'll be proving is on a square. The diagonals of a square are perpendicular. By now, you should be conversant in transforming this into an if-then statement. So you can just say if a quadrilateral is a square, then the diagonals are perpendicular. Remember that a square also is a rectangle, a square is a rhombus, and a square is a parallelogram. So you can make use of those properties uh, to prove this statement. Okay, now let's draw a square to have a clearer picture of what we want to have. Suppose A, B, C, D. Okay, you're given here a quadrilateral A, B, C, D is a square with diagonals, okay, AC and BD. Okay, and draw the diagonals. This is one diagonal here, and this another diagonal. And you want to prove that segment AC is perpendicular to segment BD. Okay, perpendicularity here indicates that there is a right angle. So let's name this angle A and then angle B. To prove this, actually here, AC perpendicular to BD, we should arrive at angle A equal congruent to angle B, and this must be congruent to 90 degrees. Okay, so to make the proof uh, here, we're going to have this, we can have any two pairs of triangles. There are one, two, one pair, one pair, one pair, one pair. So we have, you can find one, two, three, four pairs of triangles, but I want this pair here, 1 and 2, to be shown as congruent. Okay? So those triangles. So let's mark this with E. Okay? So our goal here is to prove triangle ABE congruent to triangle ABE CBE. Okay? That's our goal there. Uh, ABE, CBE. Okay, so pre-analyzing the problem, we know that this is congruent to itself because they are sides of a square. And we know that BE is congruent to itself because of uh, reflexive property. And we can just show that AE is equal to EC, or segment AE is congruent to segment EC by a property that we know. Since this is a parallelogram, the diagonals bisect each other. So if they bisect each other, then BE here is congruent to ED, but we are not interested of that. We would be interested of AE here congruent to EC here. Okay, so that we now have an SSS congruence on triangles 1 and 2. Okay, so let's start our proof again. These are the statements, and this will be the reason. Okay, what will be number 1? Quadrilateral ABCD is a square with AC and BD as diagonals, okay, or diagonals AC and BD. The reason here is that this one is given. Now, what is the implication here now? We know that AB is congruent to BC. Okay, this property can be said to have been inherited from a rhombus. The sides of a rhombus are congruent. Or we can say a theorem, but no need to have this. Okay, all sides of a square, all sides of a square are congruent. This one was inherited from the property of the rhombus. The sides of a rhombus are congruent. So now we are able to define one side here, corresponding sides congruent. And we can say here that BE is congruent to itself, BE, because of reflexive property of congruence. Okay, reflexive property. So we now have this congruent to itself. We only have to show, okay, right, that A is congruent to CD. Okay, so here, since we have a square, we say that AC and BD bisect each other. Bisect each other. Okay, this is a property of parallelogram. Okay, they bisect each other. So let's say in a parallelogram, okay, the diagonals bisect each other. Diagonals bisect each other. Bisect each other. Or you can say the diagonals of a parallelogram bisect each other. And the implication to this will be that BE is congruent to EB at the same time AE is congruent to EC. I would not be interested with BEED because I'm concentrated on these two triangles. So I can now just say what AE is congruent, segment A is congruent to segment EC here. Segment A, and then the reason here is what? Definition of bisect. Okay, now I have three sides. Okay, this is now the third side. Okay, uh, and I will now say the triangle what ABE is congruent to triangle CBE. ABECBE by, okay, SSS. And from there, I can say that angle A is congruent to angle B. And this is CPCTC. What do we know? If angle A and congruent to angle B, I can have my proof and I will say angle A and angle B are form a linear pair. Form a linear pair. Linear pairs. They are linear pairs. That's by definition, okay, of a linear pair. Okay, how did you define a linear pair? If we have these two angles, A and B, and opposite sides, opposite rays consist a line, and they have here another ray, these two here will always, they will form a linear pair. And in your previous work of geometry, if angle A and angle B form a linear pair, then they are supplementary. Okay? Then, and hence, I will say here, and hence uh, they are supplementary. Okay, they are supplementary. Okay, now, what will be another theorem that will aid us here? If you remember the supplement theorem. What is the supplement theorem? If two angles form a linear pair, then they are supplementary. So A and B here form a linear pair and they are supplementary. So this will be definition of linear pair and then the supplement theorem. Okay? We are assured that uh, they are supplementary and they form a linear pair, they are supplementary. And I can say that, uh, what do I say? What is the measure of a supplementary? Okay, measure A and B is equal to, okay, if they're supplementary, then uh, they must be equal to 180. So this is definition of supplementary angles. Okay, and I can simplify this. I can make a substitution here. Since angle A is congruent to angle B, I can say I can have this both angle A, and this will be 180. Substitution. Okay, I'll just have substitution, and simplifying this, I will have 2 times measure of angle is 180, or measure of angle A is 90 by MPE. Okay, now we have now a measure of angle A. A here now is 90. This implies now that angle A is a right angle. Okay, if angle A is a right angle, this is what? Definition of a right angle. Okay, and I have this one erase. Uh, I can continue my proof here. Angle A is a right angle, and the only thing that I can say now is if angle A is a right angle, okay, then I can say that what? Segment AC is perpendicular to segment BD. This is definition of perpendicular segments. What is the definition of perpendicular segments? They form a right angle. Okay, so we established that angle A is a right angle, and now we can conclude that segment AC is perpendicular to segment BD. AC is the diagonal and BD is the diagonal. So we have perpendicular diagonals. Okay, so that's it for the proof of this theorem.